Hello everyone, welcome to 722 Day 2. Today we're going to focus on writing equations from the graph specifically for trig functions. So our content goals for today, we again just want to make sure that we understand what a, h, and k do in the graphing form for our trig functions, specifically sine and cosine, and be able to find the value of each of those parameters in a given graph, and then use those to ultimately write the equation of the graph we are looking at. All right. So let's go ahead and get started with that. So again, we've talked about this now for a few days where we've looked at the graphing form of both sine and cosine. We've talked about the amplitude, the phase shift, and the midline. So I'm not going to go over that again to start the lesson, but if you need to see that again, you can visit some of the previous videos that I've done. All right, so we're going to jump right into a graph here, and our goal is to find these things, right? We want to be able to find the midline. We want to how do we figure out if it's a sine or a cosine that we're looking at? How do we know if it's been reflected? All of that stuff. So I'm going to go through that in detail today, and let's see what we got here. So remember, the midline is the horizontal middle, right? So if I were to draw a line going from left to right through this graph, I want to split that wave in half horizontally. All right, so the way that we do that is we look at how high the graph goes and how low the graph goes. So if I'm looking at this, I see a max located right here, and I see a minimum located right here. And I might look at, okay, where is that max at? All right, so if I'm looking at that y value, how high does it go on the y scale? It goes as high as 3, and then down here, the minimum goes as low as -5, right? So if I'm going to split this in half horizontally, I want to go for the number that is directly in between, or that is the midpoint between 3 and -5. Okay, so an easy way to do that is just to count, right? So if I count up 1, 2, 3, 4, 5, 6, 7, 8, right? So there's a distance of 8 in between the min and the max of this wave right now. So the midline would be at 4. So 1, 2, 3, 4. So that takes me to -1, and then I can draw my midline into the graph. And this would be the line that cuts our wave in half horizontally. Okay, and we always write that as an equation. So I'd say y equals -1, and when you go to put this answer into MyOpenMath, make sure you include the y equals, because it's specifically asking for the equation. All right, so now let's determine whether or not it is a sine or a cosine graph. All right, and it's good that we have the midline drawn in, because that's what I use to determine whether or not we're dealing with sine or cosine. So I always remember the start of our screamer ride, right? So when we first get on the Ferris wheel, right, we get on at ground level. So our height off the ground is 0, and height is represented by sine. So if I go to the beginning of the ride here at 0, okay, the midline would represent ground level. You notice that sine is starting on the midline. It's starting on the ground. So that's where sine would start. But cosine doesn't. Cosine has a horizontal distance, right? Cosine represents how far to the right or to the left we are of the center of the circle. So cosine always starts off the midline. All right, so since this particular wave is starting on the midline right here, we know this is a sine function. Okay, now to determine whether or not it's been reflected. So again, I think about that ride, the screamer, right? If I'm riding the Ferris wheel always starts by going up, right? If this were reflected, right, then the Ferris wheel would start by going down. Okay, so if I'm looking at this wave, notice how this wave starts at the midline and then it goes up, right? And that is the typical direction for sine. If this function had been reflected, this point would be reflected down here below the midline. Okay, so this one has not been reflected. All right, now the amplitude, that is the distance between the midline and its highest point, right? And a distance is always positive. So this is going to be a common mistake that students make, especially if we run it into a wave that's been reflected. A lot of times students will assume that the amplitude turns negative, but the amplitude is always a positive number. It is always a distance between the midline and the highest point, right? So here's my midline, here's my highest point. We just want to draw a vertical line from the midline to that highest point. So this is my amplitude. I just got to count it out. So 1, 2, 3, 4. So we have an amplitude of 4. Okay, so we have found all of the major things that we need to find here to be able to write the equation, because that's what they're asking for next. Since this is a sine function, we're going to say y equals, I'm going to start with my amplitude. That is the number that goes out front, right? That is my a value. So I'm going to say 4 times sine, and our variable inside of sine will be x. And then since the midline is at -1, that means the graph has been shifted down 1 unit. So I need a -1 on the end. And that's really all we need to write the equation. We really just need the amplitude and the midline, and we need to know whether or not it's a sine or a cosine function, and then we need to know if it's been reflected. If this had been reflected, I would need to put a negative in front of the 4. Okay, so let's give it a try again. Okay, so here we go. We've got a wave. This looks like a lot more wave than what we were dealing with in the first problem, but not a problem. We can still find the midline using the same technique, right? Look for a max, right? So we have, let's say we can even use this max over here. This one has a maximum of 1, right? And if I go across my graph, there's no point on the wave that goes higher than 1. And then I can go down here and look for a low point, right? A minimum. Okay, so if I'm looking at this, there's my minimum. Here's my maximum, so going from -7 up to 1, right? And that is a distance of 8. So if I count up 4, 1, 2, 3, 4, my midline will be located right here. Okay, so I'm going to say y equals, and we would see that is at -3. All right, so now is this a sine or a cosine function? So remember what we talked about. I go to 0, right, on the x-axis. I look at my midline, and I notice the function does not start on the midline there. It's starting above the midline. So this is a cosine function. And cosine is kind of nice because it's really easy to tell if it's been reflected. If cosine is starting above the midline, it has not been reflected. If it's starting below, it has. All right, so this one has not been reflected. And then we can find the amplitude, same way, nothing's changed, right? So I'm going to find my midline and one of the maxes. So we're going from here to here, and we draw in our line. We look for this distance. I'm just going to count it out. 1, 2, 3, 4. Okay, so this has an amplitude of 4. Remember, amplitude is always positive. Okay. So the next thing we're going to look for is the period. And remember, the period is the horizontal distance it takes for this wave to repeat itself. Okay, so if I'm looking at this, I'm going to start here at 0, and I'm going to run through one full cycle of cosine. Okay, so you'll notice, right, this is one full cycle, and if I were to continue going, we would just repeat that same motion again, right? So I've highlighted one cycle. Then if I were to keep going, this would be a second cycle here. And it's nice to be able to see the wave continue a little bit, unlike our previous graphs. So we continue this, and we can see that repetition over and over and over again. What we really want is just one cycle, and I want to know how long it takes to get through that one cycle. So that cycle starts here and continues to here. And let me get rid of that line so we can see what that is, and that is pi. Right, so we went from 0 to pi. That's how long it took horizontally to get through one full cycle of cosine. Okay, so we'd say the period is pi. Right. So let's do another one. So I noticed this one, they're going to be asking us to write the equation here. So let's start at the top. We're going to start with that midline. Okay, so this wave seems pretty flat, but it does have a maximum. It has a maximum right here. If I go straight across, at no point does this wave ever go higher than 1. All right, so then low point, I go here. Here's the low point, or the minimum, and that is at -3. Right, so if I'm looking at this, it goes as low as here, goes as high as here. We want to be directly in between, so that's going to be right here at -2. Right, so here's my midline. The midline is probably the most important thing that you need, because it really does help you figure everything else out. All right, so we got our midline in there, and I'm going to write the equation. So we're going to say the midline is at y equals -2. And I got to figure out, are we dealing with sine or cosine? So go to 0, and this thing is starting above the midline. So this is cosine. There's cosine. Has it been reflected? Nope, because it's starting above the midline, so has not been reflected. Amplitude. So amplitude's right here. Distance between midline and a max. That is a distance of 1. And now we're going to write our equation. So we have y equals amplitude is 1, so we'd say 1. We're using a cosine function, so I have 1 times the cosine of x, and our midline is at -2, so we're going to say minus 2. There's our equation. You can simplify that a little bit. You do not have to put the 1 in front if you don't want to. If it were any other number, you really do need to write it there. Okay, but 1, not necessary. All right, let's move on to another one. Okay. All right, so again, this one we're writing the equation. Let's see what we got here. We got equation of midline. So it goes here. That's our high point. Here's a low point. So it goes to -3 and +3. So the midpoint between -3 and +3 is going to be here at 0. Okay, so we go here. This is my midline. And we'll say y equals 0. Is it sine or cosine? So I'm going to go to 0, and notice that this wave starts on the midline, so this is a sine function. Has it been reflected? Well, it went up, so no, it did not get reflected. And the amplitude, so we go here, drop my vertical from the max down to the midline, so that's 1, 2, 3. So we have amplitude of 3, and now I can write my equation. So I can say y equals amplitude times trig function, right? And we'll say sine of x, and midline is 0, so I could put a +0 here, but it's not necessary, so y equals 3 sine x is the equation of the wave that we see over here. Okay. All right, guys, that's it for today's lesson. If you have any questions, make sure you let me know in the Zoom chat. Have a great day.